The big question for this segment is what methods do we use to measure human energy use, complexity and sustainability in the Anthropocene? Whilst the Anthropocene concept reflects the past and present nature, scale and magnitude of human impact on the Earth system, it is ultimately a result of interconnected drivers, complex changing structures, emergent phenomena and unintended consequences that are inherently difficult to measure. In addition, uncertainties in the quantification of the human-environmental interactions pose a challenge to decision makers concerning the appropriate policies to put in place to address the sustainability challenge. There are essentially 3 dimensions to sustainable development in the Anthropocene, with different measures relevant to each, including the economic dimension of sustainable development, typically equated with steady economic growth using monetary measures such as GDP. Secondly, the social dimension relating to a wide range of variables, including rights to health and education, and the relative priorities and actions in relation to those variables. And thirdly, the environmental dimension, including measures of environmental impact, such as recovery of biomass in landscapes and reduced use of fossil fuels. In 2012, the United Nations Conference on Sustainable Development, Rio+20 congregation, agreed on sustainable development goals that require measurement to determine the extent to which they have been achieved by the participating countries. Many of the indicators identified in the Sustainable Development Goals are inherently difficult to measure, including infant mortality rates, CO2 emissions, safe sex practices, and the proportion of land area covered by forests. To ensure sustainability is broadly understood and desired by many, best practice should avoid complexity and minimise the cost of measurement. Whilst the majority of measures of human impact on the Earth, including human energy use, have focused on interpreting the past and present, increasingly forecasts are required to facilitate changes in behaviour. Certainly any justifiable estimate of the impact of the Anthropocene will be a complex exercise, as the future is both a driver and a consequence of societal actions amplified and accelerated. The overwhelming number of possible interactions between humans and the Earth create a challenge in identifying feedbacks or interrelationships that are critical to the measurement system and that have the potential to change the system outcomes. Measurement of relevant variables must incorporate an understanding of not only current trajectories of planet changes, but also the dynamics of nonlinear and emergent future changes, as well as make viable assumptions. Despite these limitations, improvements in technology have facilitated an increase in the detail and complexity of models and support the integrated analysis of multiple aspects of the Earth system at the same time. For example, the interactions between climate, water availability, agricultural production, trade relations and food security. Models of measurement include simulation models and scenario analysis. Emergent properties, regime shifts and feedback between system components need to be captured, and simulation models or scenario analysis are often used to understand the relevant dynamics of the human and planetary variables and to provide early warning of planetary threats. Alternatively, reduced complexity models such as integrated assessment models have also been developed to capture a broader aspect of Earth system dynamics, either by using simplified representations of the different Earth system components or by facilitating the exchange of information with more complex models. In addition, socio-ecological models are based on an understanding of real-world systems grounded in physical laws for the biophysical components and economic theory and observations for the socio-economic system components. It is likely that socio-ecological systems change through time as new interactions produce new system properties, conditions and states through the process of emergence. Most importantly, validation of any model is considered good modelling practice, but is often seen as an extremely complex challenge for integrated and complex system models. Currently, there's a lack of systemic, integrated, transdisciplinary and in-depth knowledge of the relationships between the different parts of the socio-environmental systems, and this poses a challenge in effectively measuring and predicting outcomes. This lack of knowledge can be attributed to the long, relatively independent history of most of the disciplines involved. It is argued by some that there is a need to downscale the environmental information and to upscale the information on societies to ensure that any measure provides meaningful data. Types of quantitative measures to assess sustainability include benchmarks, indices, metrics, validation via audit, reporting and accounting. Sustainability accounting, also known as social accounting, social and environmental accounting, corporate social reporting and corporate social responsibility reporting, or non-financial reporting, seeks to quantify information on sustainability and focuses on the disclosure of non-financial information about an organisation's performance to external parties, including activities that have a direct impact on society, the environment, and economic performance of an organisation. The most widely known and used measurement and disclosure guidelines for corporate sustainability reporting is the Triple Bottom Line Accounting Framework. These guidelines recognise the role of financial information and shows how traditional accounting is extended by improving transparency and accountability in reporting on the triple Ps, that is people, planet and profit. The environmental factors addressed in sustainability accounting include energy, water, greenhouse gas emissions, hazardous and non-hazardous waste, as well as recycling and packaging. The social factors addressed in sustainability accounting include community investment, working conditions, human rights and fair trade, public policy, diversity, safety and anti-corruption. Finally, the economic factors addressed in sustainability accounting include accountability, transparency, corporate governance, stakeholder value, economic performance and financial performance. Recent years have seen an increasing acceptance and even enthusiasm for new reporting approaches. As a result of the triple bottom line reporting and to facilitate consistency in social and environmental information, the Global Reporting Initiative was established with a goal to provide international guidelines to organisations reporting on sustainability to external stakeholders. The Global Reporting Initiative guidelines state that reporting on economic, environmental and social performance by all organisations is as routine and comparable as financial reporting. In addition, and to help an organisation's finance teams and accountants embed sustainability into their accounting, the Prince of Wales set up the Prince's Accounting for Sustainability project in 2004. Despite these various reporting initiatives with respect to the measurement and validity of sustainability measures, the challenge of simplification of this complex area remains.